Okay, this video is the introduction to trigonometric identities. So identities are a series of rules that you can use to help simplify trig equations or to solve them, just using the symmetry properties of the unit circle. So let's start with the unit circle here. So we're looking in the first quadrant, okay, and if we just concentrate on this triangle here, where we've got an angle of theta, now we remember that this A value is the x value, A, is cos theta, and B is sine theta here. Okay. Now what we're going to do is look at this point up here where this angle is also theta, so these triangles are the same. Okay, but because we measure the angle from the x-axis, then what we're talking about is actually this angle here, pi on 2 minus theta. So again, pi on 2, bring it back, the value of theta, okay, and that gives you that angle in here. So then our point there is pi on 2 minus theta. So using the same thing, the y value is sine of that angle, sine of pi on 2 minus theta, and the x value there is cos pi on 2 minus theta. Now, because these triangles are the same, this value, this length here, A, is the same as this length here, A. So A equals A, which means we can say that sine of pi on 2 minus theta is the same as cos theta, which is your first identity here, okay, your first property. And then by the same token, we can say sine of theta is the same as cos pi on 2 minus theta, because the B values are the same. Okay, so this is your A values, and this is your B values. So we're just using the properties, the symmetry properties of the unit circle to relate the values of sine theta and cos theta with sine pi on 2 minus theta and cos pi on 2 minus theta. Now this also works when we hop over into the second quadrant. So instead of looking at coming theta back this way, we're adding theta to pi on 2. Okay, so same thing over here, we've got cos theta, sine theta. Okay, and then this value of A here is now sine pi on 2 plus theta, and this is cos pi on 2 plus theta. Okay, but of course this is now negative. So we've got a negative value, where this is positive, this is going to be negative. Okay, so that's why you have a negative value over here. These two are still the same because they're both positive, positive x, positive y. Okay, so again that's your A values, and that's your B values. Okay, so how is this useful? Well, let's have a look at an example. So we've got something here, it says sine theta is 0.3 and cos of alpha is 0.8. Okay, you want to find the values of these. Now, we could do inverse sine and inverse cos and find out what is theta and then plug that in here and work it out. But that tends to get a little bit complicated. And we can use the identities in order to make this much easier for ourselves. Okay, so for A, we know that sine of pi on 2 minus alpha is the same from our identity as cos alpha. Okay, and we've been given cos alpha, so that's just 0.8. So we don't have to know what alpha is. We don't need to know what that angle is. We can relate the two properties of sine and cos to get the value of that there. Same thing for part B. So we've got cos pi on 2 plus theta. Now we know that's the same as minus sine theta. Okay, from our identity, we've been told that sine theta is 0.3, so that's going to be negative 0.3. Okay, and for the last one, we've got sine of negative theta. Now this one might be easy to do with a unit circle. So if we draw a little diagram, okay, we've been told that sine theta is 0.3, so that means theta is somewhere over here. Okay, that's theta there. Now if you've got minus theta, it means you're coming back the other way, coming clockwise, which means you're down here. Okay, so now the sine value is obviously going to be negative, because you're on the negative side of the y-axis, or negative y values rather, so negative sine theta, so that gives you minus 0.3 as well. Okay, so you can work out these properties without actually having to calculate those angles. Okay, the next identity we're looking at is the Pythagorean identity. This is really straightforward. but it really comes in handy, particularly when you start doing trigonometric proofs and mucking around with things like that. So all it does, as the name suggests, is use Pythagoras. So if you've got a right angle triangle and you know that this is your x value is cos theta and your y value is sine theta, we know that x squared plus y squared must equal the hypotenuse squared. We know that's 1 because it's a unit circle. Okay, so if we know x is sine theta, cos theta and y is sine theta, then we can write it like that. Now, just a little word on notation. See how we put the squared between the cos and the angle? And that's to reduce confusion as to whether you're squaring, what are you actually squaring? Is it the value itself or just the angle? So this is basically saying cos theta and then square all of it. Okay, but what we say is cos squared theta plus sine squared theta equals 1. Okay, so just get used to putting your squareds in there between your cos and sine and the angle. That's the notation we use. Okay, so how can we use this one? Well, we've been told that sine of x is 3 on 5, and we want to find cos of x and tan of x. So for the first one, if we use the Pythagorean identity, we know sine squared x plus cos squared x equals 1. We know that sine x is 3 on 5, so sine squared x must be the square of that, 925. Okay, plus cos squared x equals 1. So cos squared x must be 16 on 25. And then if we take the square root, cos x must be plus or minus 4 over 5. Okay, now if you hadn't been given any more information, that would be a sufficient answer, but you've been told that x is between pi on 2 and pi. Okay, x is the angle, so that means it's somewhere in here. It's in the second quadrant. Alright, so for this to make sense, cos x can't be positive 4 on 5 because that would be over this side. That would be a positive value there. So therefore, cos x must be minus 4 on 5. Okay, so it's going to be somewhere in here. Now for tan, remember that tan x equals sine x on cos x. Okay, we looked at that in an earlier video. So if sine x is 3 on 5, and cos x is minus 4 on 5, then tan x must just be minus 3 over 4. It's as straightforward as that. So we like to use the symmetry of the unit circle to our advantage, so we don't have to do unnecessary calculations like working out what the actual angle is and then calculating the new ratio of that angle. Okay, so you can use these properties. Do remember these, although I suspect they will probably be on your formula sheet. I haven't had a close look, but I think they probably are. But remember where they came from. It's unlikely that you'll be asked to prove any of these in an exam situation, but if you remember where they came from, then if you do have that panic moment and you can't remember what it is that it means, or you start looking at it and it doesn't make sense, you can go back, draw yourself a quick unit circle and think, oh yes, now I remember why it is that makes sense. So we'd like to show you the origin of these things so you can actually go back to that at any stage and convince yourself that yes, it does make sense. The Pythagorean identity is fundamental trig identity. Okay, this comes in a lot of stuff, particularly when we start getting into trigonometric proofs and things like that. So make sure that you're happy with that. Also happy with the notation: cos squared theta plus sine squared theta equals 1. Okay, and happy at using that to find your values of cos theta and sine theta.